Okay, video part 4, Locus. Time finished before I say the last thing to find the locus of the point which is equidistant from the four vertices of the uh, uh, rectangle. If the rectangle is fixed, we don't have set of points. We just have this point because this is the only point which is equidistant at the same time from the four vertices of rectangle, which is the meeting point of diagonals of rectangle or the meeting point of the perpendicular bisectors of the opposite sides of rectangle, which are the axes of symmetries of the rectangle. Because if O, for example, is the meeting point, O is equidistant from A, B, C, and D at the same time. This means O is the set of points of the is the only point which is fixed, by the way. So that's why we don't have set of points. The locus of diagonals is the point where it is equidistant from the four vertices of rectangle. Before I move to another thing, I would like to mention this. Suppose we have a segment, only a segment, which is, let's say, segment AB, and this segment AB is fixed. What is the set of points that is equidistant from A and B at a distance of 3 centimeter from segment AB? That's great. So if we can take from here a 3 centimeter, right? Suppose this is 3 centimeter, and we can take from here 3 centimeter, or from here 3 centimeter, or 3 centimeter, right? From the other side of the straight line, from the other side of the straight line, or from here 3 centimeter, right? 3 centimeter, 3 centimeter, 3 centimeter, 3 centimeter. It's equidistant by 3 centimeter from the segment, from a given point of the segment, right? A, B. 3 centimeter away from the segment AB. All these points, they form this shape. This is straight line parallel to AB at a distance 3 centimeter. This is from the other side, also from the other side of AB in the other semi-plane that AB made. This semi-plane H1 and this semi-plane H2. We have from this side in H1 3 centimeter points equidistant from AB. So we form two parallel lines. Each one belongs to a different semi-plane. But here exactly should know that it is a semicircle, because if every point in this semicircle, it is equidistant 3 centimeter from point B, this means point B will be a center of this semicircle. As the same here, we have another semicircle equidistant from point A 3 centimeter away. So we will have this oval shape, which is two half circles, two semicircles at the two different ends, and we have two parallel lines, So this is the set of points. Okay, let me check now another exercise for this one. Another exercise. Let's say, what is the locus of the center of the circle that is tangent to the sides of a given angle? That is tangent to the sides of a given angle. What do we have over here? Let's see. If we have a given angle, for example, it's an angle. This is an angle. What is the locus? What is the set of points? Sorry. Yeah, what is the set of points of the center of a circle that is tangent to the sides of a given angle? If I want to draw a circle tangent to these two sides of this angle. Okay. First, I have to take, right, a perpendicular over here, right? Because we have tangent. This will be radius of this circle. A perpendicular also over here. And we draw the circle, right? We draw the circle. That is tangent to this side, and it is tangent to this side, side as well. That's great. If we take another place, right, this will be 2 sides, two radii of this circle, right? They are equidistant because the circle should be tangent to this and should be tangent to this side as well at the same time. We can keep taking centers, and from this center we go right to this side equidistant, and to this side same distance because they are radii. And distance is perpendicular, and the radius should be perpendicular to this line as in order that the circle will be tangent to that line. Also, we can take this point, and it will be a point circle, just the center, right? So if we join all these points, we get what? Simply we get the angle bisector, right? The angle bisector, and we can prove it. We can take this is as M, this is as A, this is as B, and this is as O. First, in these two triangles, OMA and OMB, what do we have? We have OM equal OM, common side, or reflexive, right? What else do we have? We have MA is equal to MB, because radii to same circle. And what do we have else? We have this angle here, 90, and this angle 90, because radius to the point of tangency is perpendicular to the tangent. So in these two right triangles, we have this common side or reflexive, right, which is hypotenuse in both triangles. And what do we have? We have this equal to this because bisector of an angle, or we can say OA equal OB, because, sorry, we don't talk about these two angles because we're proving it is the angle bisector. So we take this OA equal to this OB, because from a point outside the circle, tangents that are drawn are equal. So what do we have? Again, OM equal OM, OA equal OB, and MA equal MB. So what do we have here? Without taking the right triangle, we can say the two triangles are congruent by side. If we took the right angle, so the two triangles will be congruent by hypotenuse and leg, right? Hypotenuse and leg. In both cases, these two angles are equal. Corresponding parts of congruent triangles are congruent. This means this line will be the angle bisector of angle AOB, or XOY, whatever. Also, this is important. What else? So we still have some activity, I guess, or no, or some example. Let's see if we can do it in this video. Prove that the locus of points at a given distance from a line is a pair of lines parallel to the given line and at a given distance from it. We did that already, guys. We did that already. If we take a look at this one here, at this one, without mentioning this part and this part, right? Because we have a line, not a segment. If we have a line, what are the set of points equidistant from this line? Again, equidistant, having the same distance. From each point we form, we take a distance, which is the perpendicular, or if all these distances are equal, these points, they form a line parallel to that line. But we have another side, we can do the same thing exactly with the same distance d, for example, and all these points, they form another line which is parallel to that line, right? So the set of points in this case will be these two straight lines in these two different semi-planes with respect to that line. At a given distance, they are parallel to that line. Have fun.